Hi friends, we're going to do a little bit more work today with circles. We're going to look at the expanded form of the circle equation. Here's your anti-set. Go ahead and pause the video and give these couple problems a try. And welcome back. I'm going to go ahead and go through the solutions for you. The center for this one is at 3, -4, has a radius of 3. The center for this one is -2, 3, has a radius of 5. And the center for this one is 3, 8, and it has a radius of the square root of 17. Today, our objective is to identify key features of a circle from the expanded form of the circle equation. So this is going to be looking at a different form of the equation. And we would want to look at this because if we're making a digital image, we might have to use a program that only accepts an equation in a certain form. So to help us out with this, I wanted to review completing the square on quadratics. We did this way back in our 4th unit, so October. So you might have a foldable in your notebook if you have your notebook at home with you on how to complete the square. I'm going to go through this problem with you. Step 1 is to put it in the form of x squared plus bx equals c. So that means that we want to have no coefficient on the x squared. So if we have an a there that's not 1, we have to divide everything by a, and we want to subtract the c to the other side. So that would give us x squared plus 4x equals -9. And then the second step is to add b over 2 to each side. And in this case, b is 4. So x squared plus 4x. 4 divided by 2 is 2. 2 squared is 4. And we have to add it to both sides in order to balance the equation. And then we're going to simplify each side. And when I say simplify for the right side, that means I want you to factor it into its perfect square trinomial. And then we would just need to get the right side simplified by combining like terms. And then we would square root each side. So we get square root here, square root here. X plus 2 equals square root of -5. Then solve for x. So we could get x equals -2 plus or minus I root 5, where we're taking out I as the square root of -1. So hopefully you remember that from way back in October. If not, hopefully it's not taken too much to come back to you now. We're going to use that when we convert the expanded form of a circle equation into standard form. So what we need to do is we need to actually rearrange this equation to collect our x terms. So x squared minus 2x plus y squared minus 10y. And then much like in the completing the square, we're going to move that c term over to the other side. The next thing I'm going to do is I'm going to go through step 2, add b over 2 squared to each side for both the x term and the y term. So x squared minus 2x, in this case, b is -2, divided by 2 is -1, squared is 1. And that means I'm going to need to add 1 to the other side as well. And then we're going to take a look at the y term, y squared minus 10y. -10y divided by 2 is -5. Squared is 25. And so I need to add that 25 to each side. Okay. And then I can simplify. Step 3 is still going to be simplifying. And I can do x minus 1 squared plus y minus 5 squared equals -17 plus 1 is -16. -16 plus 25 is 9. So then I can utilize this information to help me find the key features of my circle. The center of my circle is going to be 1, 5, and the radius for my circle is going to be 3. And so we can utilize that information on this next page, or on one of your we can use that information on one of your Khan Academy practices. And we can just kind of remember, we can write the standard equation of a circle. So for this particular circle, we can write x minus 9.2 squared plus y plus 7.4 squared equals 5 over 3 squared. And we could actually go through and do the multiplication on this one and rearrange it to get it into the standard form, or the expanded form. If you would like to see that done, please click on the image and it will take you to a detailed video on how to do that. I'm not going to show you that here because it's not necessary for your practice on Khan Academy today. So we had just actually done this example where we got that the standard form of the equation is x minus 1 squared plus y minus 5 squared equals 9. So the center of this circle is at 1, 5, and the radius is 3. If you want another example or you want to see more information on how to solve a problem like this, please go ahead and click on the image in the slides and it will take you to a video with more information. Okay. Here's another example of a Khan Academy practice I'm going to have you do today. I've given you the expanded equation of the circle, and we can utilize the information that we just had to put it into our standard form. So x squared minus 12x plus y squared plus 6y equals negative 36. X squared minus 12x plus 36. Adding that b over 2 squared to each side, y squared plus 6y plus 9 equals negative 36 plus 9. So simplifying into x minus 6 squared plus y plus 3 squared equals 9. That tells me that the center of my circle is at 6, negative 3 with a radius of 3, and then I just graph it that way. Again, for another example or for more information on how to solve a problem like this, please go ahead and click on the video for the picture for a video tutorial. So you have practiced today 2 Khan Academies on features of a circle from its expanded equation and graph of a circle from its expanded equation. I timed myself and did both of these modules twice and made a mistake with them and didn't have my materials, and I was still done in less than 7 minutes. So hopefully this will take you less than 10 minutes. If it is taking you more than 15 to 20, please send me an email so that we can figure out where your misconception is and help you utilize your time more efficiently. So our objective today is to identify key features of a circle from the expanded form of its equation. Hopefully you see how to convert from the expanded form to the standard form. Many programmers require this. Also, SAT. Every single year, I see at least one question on SAT where it asks students to take the expanded form of a circle and utilize that in standard form some way, whether it's matching the graph or finding the radius or using it to solve a problem. So it is important to be prepared with how to convert between the standard form and the expanded form for your SAT. So for your closure in your notes, I'd like you to compare and contrast completing the square on a quadratic, like we did back in October, to completing the square to find the key features of a circle from the standard form of the equation, like we did today. So go ahead and write that in your notes. Thank you so much for joining me on our video today, and I hope you are well.